In the last class, we started this protocol ISIS. This intermediate system to intermediate system link state routing protocol uses same algorithm like OSPF, send hello packet same like OSPF. Tell me how often OSPF send hello? How often OSPF send hello? How often OSPF send a hello packet? Same timer here also. ISIS also sends hello packet every 10 seconds. Every 10 seconds. ISIS and OSPF hello timer is same, but hold timer is not same. What is the hold time for OSPF? 40. ISIS is 30. ISIS is 30. That's another difference. I repeat. Hello is 10 seconds. Hold time is 30 seconds, not 40 seconds for ISIS. For OSPF, I'll write in blue. For OSPF, this is same 10 seconds, but this one is 40 seconds. Hello is every 10 seconds, hold is 40 seconds for OSPF. That's one small difference in the timer. Secondly, tell me to which address the hello packets are sent in OSPF. Well said. What is that multicast address? Exactly. We don't have any layer 3 multicast address for ISIS. We don't have any layer 3 multicast address for ISIS. Why? Because ISIS works in layer 2. Don't forget. These are all very important fundamental, you know. See, OSPF works in layer 3. ISIS works in layer 2. ISIS works in layer 2. OSPF works in layer 3. So ISIS will be using a layer 2 multicast address. That you don't need to really memorize that multicast address. One thing you should be very clear, ISIS works in layer 2. I told you yesterday, ISIS was even before IP, even before OSI. So this ISIS is altered version to fit into OSI. And where does it fit? It fits in layer 2. Right? So these things are not in the presentation. That's why I'm mentioning it. It's not in the presentation anywhere. Okay. ISIS also have got this 2-level approach, 2 hierarchical level. 2 hierarchical level. One is to interconnect between the areas. Those interconnecting area will have L2 adjacency. Yesterday when I was closing the class, I was telling you there is L1 neighbor, L2 neighbor. By default, when you enable ISIS, it will be both L1 and L2. By default, when you enable ISIS, it will be both L1 and L2. But here we have disabled L2. Here also we have disabled L2. Why? We are not talking to other area. L2 is needed only if you are talking to different area. Only if you are forming neighbor with different area. So we have killed the L2 level 2 process. To save the routing process utilization, we have killed, we have suppressed L2. But if you see this router is running L1, which is default, and L2. It is running both L1 and L2, which is default. So using L1, it can form neighbor with the same area member. Using L2, it can form neighbor with the other area member. There are a lot of things here you should be noting it down. There is no ABR. You see, if I have one router in area 0 and also in area 1, we call it as an ABR. In OSPF, there is no other option. Why? Because for this port to form neighbor with this port, both should be in same area. If this is in area 1, if this is in area 0, they won't form neighbor in OSPF. They will not form neighbor. So you need to take this router and make it as a part of area 0 as well as part of area 1. Whereas ISIS can form neighbor when the router ID is, when the area ID is different. You see, this port is in area 1. The other end of the wire connecting port is in area 2. ISIS allows this neighborship. ISIS allows this neighborship. Yeah. So this is a very important fundamental difference. ISIS can form neighbor with the router which is in different area. This is in area 2. This port is in area 1. With the help of L2 adjacency, this can form neighbor. For L1 adjacency, it should be in same area. You see, both are in same area, area 1. This port is also in area 1. This port is also in area 1. L1 adjacency will happen. L2 adjacency is not needed here because we are not talking to another area, so you can suppress it. We have suppressed L2. When you enable ISIS without mentioning L1 or L2, level 1 or level 2, as I said, by default it is both L1 and L2. Okay, now listen to this picture. Area 1, this is the boundary. This is area 4 boundary, area 3, area 2. Whatever the area 1 has got, the networks that has got, whatever the network that area 1 has got, To give it to another area, only a L2 neighborship can do it. L1 neighborship cannot give update to other area. L1 neighborship will not give route to other area. That is why we did not suppress L2 here. We need L2 here. We need L2 here. We also need L1. Only then the route from this L1 will be taken and converted as L2 and given to other area. So definitely the router in the border of each area will be an L1 and L2. So here also L1 and L2. But the internal router is L1 only. In this area, I don't have internal router, so I just have L2 only. I suppress L1 because there is no need for sorry, yeah, correct. I suppressed L1 because there is no need for L1. There is no internal router to form L1 adjacency. L1 adjacency is an adjacency with the same area member. And now, why is this router L1 and L2? We understood this is talking to other area. This is talking to other area. Can anyone answer why this router is L1 and L2? The reason is it is in the path. If you don't have L2, then the route given by other area will stay here and this will not take it. See, if other area route need to be distributed like this, it goes from here using L2. Using the same L2, it goes here. Using the same L2, it goes here. Using L2, it comes here. If you don't have this L2 here, if you just got L1 there, if this is only L1, the route that is coming from here to here will not go to the next router because this is L1. It says give me only the local area network. L1 will say only give area 2 network. Don't give me L1, don't give me area 1, area 3, area 4. Don't give me area 1, area 3, area 4. Just give me, I belong to area 2. You give me only area 2 update. L1 will only learn local area. So if it learns only local area, if this also learns only local area, then how will area 1 route from here will go to other areas? Same way, how will area 4 route that is going from here will be given to area 1? Not possible. So understand, you need to have all the routers in the path L2. You need not to have the entire area with L2. See, this router is not having L2. This is not a backbone area. You should not call it as backbone area. In OSPF, all router will be area 0 backbone. But here, that's not the case. It is L2 the one which makes backbone. L2 the one which carries other area routes. So if we need to make sure all routers in the path will have L2, then why I need L1 here? If I don't have L1, then local area network will not be seen in this router. So I need both. Yeah. Now, integrated, meaning what? both, means dual. In Cisco router, some commands are still CLNS. Some commands are still using CLNS. Show CLNS neighbor. Instead of show IP ISIS neighbor, we type what? Show CLNS. What does that prove? It proves that IP and CLNS dual integrated coexist. Yeah. You see? So we have ISIS for multiple protocols. Here in normal routers, you will have both IP and CLNS. But if you take if we take Nexus device, ISIS is used in various concepts. I told you this one in the previous class, like fabric path. Have you heard about ACI, Cisco Application Centric Infrastructure, ACI, Cisco Data Center Device? That also uses ISIS. That's a SDN concept. Not SD-WAN, it's an automation. It's an SDN concept in data center, Cisco Nexus. Okay. Like OSPF having its own LSA types, ISIS also has got PDU. What does PDU stands for? Yesterday I told you. I told you we don't call LSA, we call LSP, and the P stands for PDU. What does PDU stands for? I also gave you a simple word to replace with this PDU. What is that? Packet. Very good. And what does the PDU stands for? Protocol data unit. Protocol data unit is nothing but the data that belong to this protocol. It's nothing but update. It's nothing but routing information. PDU, protocol data unit. Okay. It uses its own PDU to transfer IP routing information. All right. So IP packet is not the one which is carrying the update. It is LSP. LSP, which is using multicast. Which multicast? Layer 2 multicast. That is why it is not an IP packet. It's a layer 2 packet. I told you, hello packets are sent to layer 2 multicast address. And also it need a CLNS address to identify. I told you, ISIs don't use router ID. Router ID is like a 32-bit format. 8-bit dot 8-bit dot 8-bit dot 8-bit. 32-bit format. Which is used as a router ID in OSPF. But in ISIS, I told you, it follows CLNS address, which is called as net ID. Network Entity Title. Net ID. Right? We will talk about this in detail later. Okay. This is a very important page. Integrated ISIS design principle. What do you see in this picture? You got many areas, at least 4 areas. And inside the area, you got only L1, except the core area. In the core area also, you have only one path with both L1 and L2. The router on the top, which is L2 only. So what happens? This is one area actually. No, not this one. Why they have this is not the right picture. This picture is not correct. This should be L2 within the cloud. Okay. IP and CLNS address must be planned. Okay. Two-level hierarchy scalability. So what is the advantage of two-level hierarchy? Limits LSP flooding. Meaning you're not going to send all the route updates to other area. You will be summarizing the borders, right? So limited LSP only getting flooded. Same story what you learned in OSPF. Why you have OSPF with multiple area? To localize the impact of topology change, to get a summarization point, to reduce the detailed LSA getting flooded. That is what here in another word said limits LSP flooding. Next, provides opportunity for summarization. Yes, because you got multiple areas, you can summarize on that L1, L2 route. I think this picture should be drawn like this. Yeah, now it makes sense. You see, using L1, this will all talk. And using L2, these two will talk, and all this area network will be given to this guy. And this guy will give to this L2. And this L1 will take it and give it to this guy if needed. But these guys can now ping these routers through the route which this has learned. So you need only L2. There is no need for L1 there. So the only router in this area is this. This is the only router in this area. This one. Now it makes sense. Yeah, I can see that actually. I can see the cloud there. The cloud here. This is the only router in that area. So this is all part of the below area. So this two level of hierarchy definitely provides an opportunity to do summarization. You summarize here and send it to the core so that it will give only the summary to this guy. So summarization is going to limit the update traffic, minimize the root router's memory or CPU. How? Because you are not going to send too many LSP. You are not going to send too many LSP. You are going to summarize and send, not too many. As a result, the CPU utilization, memory utilization will be less. Okay. Issues with integrated ISIS. So what is the problem in this ISIS? By default, only 6-bit is reserved for metric under the interface. And 10-bit is for the end-to-end path metric. I repeat, For the cost, which is called metric here, for the cost on the interface, you have 6-bit. With that 6-bit, 65535. With a 6-bit, how much you can have? 63. 63 is the maximum you can give. The default is 10. You can set 63 as the largest metric. You cannot go more than that. And from end to end, you have only 10-bit for the metric. See here, total metric is 10 plus 10, 20. This number should not go beyond 2 to the power of 10. 2 to the power of 10, I think it will somewhere around 1024. So your total metric cannot go beyond this because you got only 10-bit. We call it as path metric. Interface metric is 6-bit, path metric is 10-bit. But you have an option in Cisco. Almost all router today is 15 plus version. We don't have 12.0 version anymore. Those things are very old. So if you see, you can go and increase this bit from 6 to 24. That is what called as wide metric. For many, this is a very big doubt. What is wide metric in ISIS? Wide metric is nothing but increasing the number of bits from 6 to 24 under the interface and 10 to 32 for the path metric is what called as wide metric. See, you are going to just type metric type wide, that's all. You put the command metric type wide. As soon as you put, automatically the 6 will become 24, this 10 will become 32. You don't need to mention 32 and 24, no need to do that. As I said earlier, the default metric in the decimal value by default on all interface is 10. Do you have any question up to here? This is not for us actually. In olden days, even computer was partaking in ISIS, so it was called as end system. Between computer and the router, we used to call it as ESIS. Nowadays, we don't have this, so don't need to worry. Now, this is also not needed. It has got L0, which is yes, not needed. Now, let's read this. Similarities between ISIS and OSPF. Integrated ISIS and OSPF are both open standard link state routing protocol. This is a similarity. Both are link state representation, age time, both have got age time, though the timer is not same, but both have got some timer, right? Hello timer is same, 10 and this is also 10, that is also 10, but whole timer is not same. This is 30. OSPF is 40. Both have got LSDB, link state database. So within an area, all the routers will have similar LSDB, both in ISIS and OSPF. Both uses SPF algorithm. Both sends update. Both take decision based on the LSDB. Flooding using the layer 2 multicast address, not broadcast. Both supports VLSM, both are scalable. That is why we see in ISIS. Both are very fast in convergence. These are all similarities. Can you give anyone, Darshan, you try to say answer for this? Any two difference between this ISIS and OSPF apart from the timer? I'm sorry? Yes, tell me please. Correct. What about the router ID? They don't have router ID. Instead, they have what? CLNS, net ID. Hmm? Okay. Any other difference? There is no ABR. Another difference. The routers of two different area can form neighbor. In OSPF, it is not possible. In OSPF, when the hello packet is sent, the hello packet should have same area ID to accept that hello. But in ISIS, hello packets will carry area ID, but that need not to match to form neighbor. The hello packets are acceptable even if the area ID is mismatching. Area ID is not a match criteria. So I have a router in area 1, another router, area 2. They can form neighbor very well. This is area 2 port, area 1 port, provided you have L2. They will form neighbor. It works on layer 2, correct. OSPF works in layer 3, ISS works in layer 2. Super. Very nice difference. Okay, let's go to the next page. Okay, the design. This I already told you. OSPF will have a EBR. In OSPF, you have stab, totally stab, all those concepts. In ISS, you don't have that. You don't have stab, totally stab, not so stab. You don't have, and it is not needed. That is why everyone likes ISS. It is not because they don't have stab. It is because there is no need for stab. It is having something inbuilt. It's having something inbuilt. So there is no need for stab. OSPF is based on central backbone with all area attached to it. We don't have the central backbone area. In ISIS, only L2 needed for distribution of one area route to another area. We don't need a backbone area. We need only L2. Here, each link belongs to one area. In OSPF, this link belongs to area 0, this link belongs to area 2. Each link belongs to one area. In ISIS, each router belongs to one area. You see? In ISIS, each router belongs to one area. So this router belongs to area 49. Sorry, area 0. This router belongs to area 2. This 49 represents private area. 49 represents what? Private area. In the private area, area ID is 0. This is area ID is 2. ISIS is more flexible when extending the backbone. How? You just need to have L2 to extend the path. See the problem with OSPF. OSPF have got too many LSAs. No, we learned router LSA, net LSA, summary LSA, external LSA, all those stuff. You don't have something like that here in ISIS. In OSPF, you have too many LSAs. It was too much for us to learn. In ISIS, for L1, you will have L1 LSP. To form L2 adjacency, you have L2 LSP. That's it. If you want to add something, you can extend the field height length value. It's an expandable. It's an extendable header. The PDUs are extendable. It is integrated. It supports both CLNS and IP. So you can extend and adapt to the change. Okay. Advantages of OSPF. You have many area types like normal area, stub area, not so stub area, totally not so stub area, blah, blah, blah. You don't have that, those things. I don't know whether to take it as an advantage. According to me, I don't take these types as advantage. You don't have these things in ISS. In OSPF, metric you can configure. If you don't configure, it will try to generate one based on the bandwidth, auto generate. Here it is always 10. Every port is 10. I don't know, some people will see this as disadvantage, but according to me, we have to configure cost manually. That is why they just want to leave it as 10 default. You go and change it according to your policy. Okay, this is one point valuable. OSPF is supported by many vendors, not ISIS. Why, you know? You don't have too many engineers who knows ISIS. Many people know OSPF, but nowadays I'm seeing a lot of people learning ISIS. But olden days, you know, everyone were going for OSPF because OSPF is easy to configure and understand. Actually speaking, ISIS is easier. You see, that is what the next point is. Informations, examples, experienced engineers are easier to find for OSPF. For ISIS, it is little tough, but not much tough. Right, this is a very important chapter. We have learned a lot of fundamentals. After this, in the next class, I'm going to take you to a ISIS hands-on lab. I'm going to take you to a hands-on lab for you. Afterwards, we will do the remaining theory. In this page, this one I want to explain. ISH. ISH is nothing but intermediate system halos. Or like OSPF halo packets, it's ISH. Intermediate system halos. Or it may be intermediate system host, or if it is host, don't care about it. We'll talk about halos in the next class. Right. So